We have one more variety of problem to discuss for this chapter, and it's this sort of overlapping triangle problem. I like to call these overlapping triangles. We actually have two right triangles in this picture. And this is the description of the setup. We have a balloon, B. A balloon is 100 meters above the ground. So the given information is given in green over here. A balloon is 100 meters above the ground. Terry, at point T, has an angle of elevation to the balloon of 38 degrees. Again, that's given in green. And Chris's angle of elevation, Chris is over at C, Chris's angle of elevation is 26 degrees. And the question we're asked to find is how far apart are Terry and Chris? So let's label this with some values here. Let's call this distance that we're looking for X. So ultimately, our goal is to find that value. And we might as well already go ahead and put it in. We know this is going to be in meters. So let's genuflect to the physics people and put our units in here. So our goal is to find the distance between Terry and Chris in meters. Now, what we have is given some information about this triangle. Now, we have two triangles present. In the small triangle, in triangle GBT, right, we have a triangle this way. We have this angle given. We have this side given. And from that, we can find this distance. Well, the problem is we don't need to find that distance. So let's leave that for a moment. In triangle, the outside triangle, GBC, we have this angle given at 26 degrees. We still know this side is 100. We are now ignoring this piece of the picture. And so from those two, we can find, for example, this distance. Problem is we don't want that distance. We want the distance between C and T. So in the small triangle, we can find the distance from G to T. In the large triangle, we can find the distance from G to C. And that should give us a piece of information here. If we find those two distances, all we need to do is subtract them, and that'll give us the difference, which is the distance from T to C that we want. So the distance between Terry and Chris is going to be given by the distance from the ground point below the balloon, from G all the way to Chris, find that value, then find G all the way to Terry, find that value, subtract the two, and that gives us the value of X. So what I'm going to do is I'm going to introduce a little bit more notation. Let's call this distance between G and T, let's call that distance Y. Let's call this grand total distance Z. And I'm going to get this out of the way. So we can use the inside triangle to find distance Y. We can use the outside triangle to find distance C, subtract them, and that should give us the value of X. Now, to find the given piece we need, it's the same process as before. We notice what piece of the triangle are we given, what piece of the triangle do we desire, and then we choose the appropriate function which gives us those values. So this might be a thing for us to do. Why don't you try this? Pause the video now, see if you can work this all the way through by yourself, and then we'll turn it back on. We'll see if you can see if I can come up with the solution that you got. All right, so let's see how well I can do this. See if I can match your work. Let's work with the small. It doesn't matter which one we find first. We have to find them both. So let's work with the small triangle first. So in triangle GBT, again, the order we find these is irrelevant. In triangle GBT, we have this angle given. From the perspective of this angle, 100 is given, that's opposite. Y is desired, that's adjacent. So from the perspective of this angle, we have opposite and adjacent, right? Opposite and adjacent. The angle, the function we need is tangent. Remember, SohCahToa tells us tangent is opposite over adjacent. So we know tangent, all we need to now do is write it. We know tangent of the angle in question is equal to opposite over adjacent is don't know yet. Cross multiply, set those equal and solve. So when we cross multiply, we have y times tangent of 38 degrees is equal to 100 times 1 is 100. Divide both sides by tangent 38 degrees. Oh, try that again. That's going to be 100 divided by tangent of 38 degrees. And let's go to the calculator. What I have is 100 divided by the tangent of 38 degrees. That gives me 126.994. I'm going to round this to 4 decimals. So I have, this is equal to 127.9942. And that's meters so far. Well, that is distance y. Next piece of the puzzle, find distance z. And it very much is, same song, second stanza. In the large outside triangle, we simply ignore this piece of the picture. In the large outside triangle, we would have this angle given, this side given, this is opposite, side opposite, and side z, that is the adjacent side. So I'll move over here. So in triangle GBC, in the large outside triangle, we have opposite, we have adjacent, that's once again tangent. So in this case, we have tangent of that angle is 26 degrees, is equal to side opposite is still 100, but now the adjacent side is all of z. Again, cross multiply, set equal, and solve. So we have z times tangent 26 degrees is equal to 100. Divide both sides by tangent 26 degrees. So z is now equal to 100 over tangent 26 degrees. And let's go to the calculator. So what do we have here? This is 100 divided by the tangent of 26 degrees. And I have, let's try that again. We have 100 divided by the tangent of 26 degrees. I have 205.0304. 205.0304. I will round that. And so that is the grand total distance from G to C. And so the last piece is straightforward. The piece we're looking for, X, the distance here, is the grand total distance, subtract off the piece we don't want. So that's distance Z minus distance Y. 205.0304 minus, what's my number there? 127.9942. And I have 205.0304 minus 127.9942. And that gives us 77.0362. And let us suppose, I didn't give this in the problem, let's suppose we were given, suppose we want this rounded to the nearest meter. Round this to the closest meter, let's say. Again, that would need to be given in the problem. If it weren't, just state the entire expression. But suppose we want this rounded to the nearest meter. Rounding to the nearest meter is just 77. So this is 77 meters distance between Terry and Chris. So, overlapping triangles. Take the picture apart from itself. The small triangle finds one distance. The large, ignore this, the large outside triangle finds the other distance. And we want to subtract the two to find, subtract those two values to find the piece we're looking for.